morning, ladies and gentlemen. So thank you very much for coming to today's CWS seminar. Many of you have made a very long way to come, including our speaker today. So it's our pleasure having Elo. She's the coordinator of ideation project, which we are collaborating with her. And so it's a good opportunity. She's coming to here for a workshop this afternoon. But that's, since she's here, it's a good opportunity for her to share what we've been doing in the ideation with all our audience. And so, Elo.
Thank you very much, Albert. Thank you for inviting me, and thanks the audience here in Exeter for participating, and thanks to everybody online to be here also. I'm Eloisa Vargiu. I work in CETaqua. CETaqua is a water technology center located in Barcelona, Santiago de Compostela, and Malaga in Spain, and also in Santiago de Chile in Chile. And we cover all the water life cycle. We have different departments, each of them specialized in a specific aspect of the water cycle. We are part of the Veolia group. We are Veolia Spain, actually, and so we work with all the companies that are located in Spain that belongs to Veolia. And we are the innovation department for them, so we work a lot with them to improve and to add innovation to their business, let's say. And among other departments, I belong, together with Joan that is here, to the digital water department. So our focus is on digitalization of water. That is something not so new, but very, very active and more relevant right now, and is where the ideation project was born. Actually, the ideation born is a collaboration of different partners. I have a slide when I will show the partners of the project, but I want to point out that this project was born from the Water Europe working group that I was leading together with Roberto Di Bernardo from engineering, and now is an expert group that I'm leading together with Roberto and also with Demetris Eliades from HIOS. And in this working group that is also participated, for example, by Lydia, is where we start thinking about new ideas, about having this kind of digital twin and this kind of activities. We come from fresh water, we come from inland waters, but then when we see this call, we thought that it was our call, and so for that we participate. So today I will give an overview of the overall project that is about digital twin of inland waters, and I have just to be sure, okay. And I want to give you a view where it is, where everything was started and where we are going. And so, it was working before.
No. Don't worry.
I may use also this. Okay. So the project of the presentation overview. First of all, I will give some hints, just some information regarding the Digital Twin Ocean initiative. That is a European initiative. That is where everything started, because ideations go together with the Digital Twin Ocean, the DTO, because we are aimed to be interoperable, to make something that will be then going together with the DTO to have a unique digital twin. And then it is where I will start talking about ideation. Okay. So the European Digital Twin Ocean is an initiative that was founded by the European Commission 3-4 years ago. And the idea is to have this virtual replica of the ocean in order to have data models, everything connected, to have a view, digital view of what is happening in the ocean, in order to have some also forecasting, to have some some hints or how to actuate in case of some emergency situations and the kind of thing, and also to have an idea of how to improve everything there. I mean, in the sense that, there are problems regarding microplastics and pollution. So having this digital twin allow to have these scenarios in the virtual world that may help in the physical world to actuate. And so in the case of the DTO, they are using satellite data, they are using marine data, they are using advanced model, they are using artificial intelligence, and they are also including the citizens in all the process because it is important to reach the citizens and also to show the relevance of what we are doing as scientists, let's say, in this world, because, of course, water, the ocean, is something that is very close to our normal life, so it's important also to involve and to empower citizens in that sense. And so, starting from that, they started to define different scenarios where the DTO could be helpful for having this monitoring and that simulation of the ocean. So they started defining different scenarios. I put here what they put in their documents, in their last deliverable, and what they are doing now is, from one side, they have a big project that is called Edito Infra, and this project was a 3-year project, just finished in January this year, but now in April just started the Edito Infra 2. I don't know if they maintain the name or not, but the second part just started now in April, because the European Commission say, okay, you're doing a very good job, but you don't have finished, so you have a lot of work to do, and so they founded another one. What they are doing is to give a platform, an ecosystem, with data that are accessible. Not all the data, of course, are public. There are different kind of access to the data, of course, but they give access to the data, to models, in order that also you may ask for access, because they are now in the beta testing phase, so you may ask for access, and you may play with the data. You may simulate your coastal water issues, just to say how a model could help in forecasting, in predicting, in whatever you need. And in this way, it's very useful for the scientists, and this is open, as I said. But in parallel, there are, under the Mission Ocean, there are several calls every 2 years asking for new applications to be done over the Edito Infra, over the DTO. So you may have a case study that you want to apply and you want to test. So they are founding also this kind of thing. I was last year to the DTO forum, and there were a lot of projects there, everybody showing their demonstration, what they were doing, and all these things are very relevant for the DTO, because they can improve, and they can also indirectly also gather new requirements for the DTO. So they define these scenarios, they define who are the beneficiaries of this solution, and of course there are the marine and coastal policies to test the effectiveness of planned infrastructures. There are of course researchers that may access the impact of human activities and climate change. They are the blue economy stakeholders to ensure sustainability by reducing environmental pressures. And as I said, everybody, we are all citizens. We are scientists, but we are citizens first of all. So everybody can contribute, and everybody can be empowered by these kind of projects. That is also very, very, very good. So this initiative started some years ago, and it's going very well. There are 2 companies that are working on that. One is Mercator in France, and the other is Bliss in the Flanders. And there are a lot of ecosystem of other projects that work together and work around. But something is missing, because water is not only ocean, of course. So one day they discovered that it's not only ocean, the part of water that should be and must be the interest of the European Commission. And so I put here the different kinds of inland waters, because it's when the European Commission say, okay, we have the digital twin ocean, we have this ecosystem, we have the platform by Editor Infra where people can play, we are doing a lot of work, but we are missing the inland part. And they don't want to have them separate, because actually they are not separated. I mean, when we have to say in English. When we have the snow that
melts.
Okay, that melts. Thanks, sorry. Then through rivers or whatever, it's arrived to the sea. So basically to the ocean. So everything is connected actually, no? And then so there is a water flow from the mountain to the ocean, let's say. And so they discovered that everything is connected, and they don't want to have two different things, two separate things. They want to have only one thing. And it's where ideation came, because they asked for a solution for a digital twin of inland waters, everything that is on the right part of the image, that is interoperable, that it means connected with the left part, that is the ocean, that is the DTO that already exists. So they opened a call 2 years ago, and that was asking roadmaps to integrate into the digital twins the inland waters. So we applied for that, and we won the coordination and support action, that is ideation, that is the one that I'm presenting. It started 1 year ago. We are in the half, almost in the half part of the project. It's strange, but it is true. And in 1 year, we will finish. So in 1 year, we have to go to the European Commission with a roadmap, with what we consider that is relevant to have for having this digital twin or digital twins, depends on how you see it, for inland waters that is integrable and interoperable with the DTO, with the digital twin ocean. We are 11 partners. We have Exeter, of course, here. Thanks, Albert, for your work. And we have another associate partner that is in Switzerland, is our expert on snow and ice. And we are CETaqua, we are the coordinator of the project. And also in Spain, we have the Barcelona Supercomputing Center. In Italy, we have CMCC and we have engineering. In Cyprus, we have the University of Cyprus. In Greece, we have CERT. In Germany, we have FIWARE. In Belgium, we have Water Europe. And in the Netherlands, we have KWR, that today is represented also by Lydia. Thanks, Lydia, for coming. So this is the consortium. We cover all the disciplines that are needed in this kind of project, because to implement, to define this roadmap, we need experts on water, of course, and for that we have KWR, for that there is CETaqua, there is the University of Cyprus, there is Exeter. We need experts on digitalization, and this for that we have companies like engineering, or we have the Barcelona Supercomputing, or we have a technological center like CERT. And we also want this connection to the digital world, to the data space. There is not yet a water data space, but there is something that is moving in that sense, that also we are doing in other projects like Waterverse. So we have also experts from the data space world that are the FIWARE Foundation, that works a lot also in a European project related to water, not only to water, but they're a very good team working on that. So we are covering more or less all the disciplines that we need. And last but not least, we have also expert on meteorological aspects, that is the CMCC. So, which is the aim of ideation? More or less I already said, but just to point out, ideation aims to prepare the development. We are not going to develop anything, but we are going to prepare the development of the digital twin of the inland waters. So we are considering all the inland waters that I put in the previous image, so snow and ice, rivers and estuaries, lakes, reservoirs, wetlands, groundwater, coastal waters, and urban water. And the goal is to have this roadmap that say not only which are the requirements, not only which are the cases that we have to take into account, but also how this digital twin must be implemented to be interoperable with the digital twin of ocean. We don't need two things. We only want an hydrosphere digital twin that covers all the kind of waters. That's what the European Commission is asking to us. Very high-level concept of the project. We have basically what I call the two inputs. From one side, experts, the multi-stakeholders. Multi because we are considering different disciplines. They can mean expert on water, they can mean expert on a specific type of water, they can be an expert on digital twin, they can be expert in digitalization without any specific expertise on digital twin. We need different kind of experts, everything together, because we need to cover these different disciplines and also to learn from different expertise and experts. We decide not to cover as a whole the entire Europe, but to approach the problem as according to a divide et impera approach. So we decide to collect information, feedback, requirements from different sides. We started from the water-oriented living labs that were defined and were created by Water Europe. Some of them are covered by them. Then we added also the rest of countries of the project that weren't covered by the water-oriented living labs, the walls. And also we start adding other sites because we start disseminating the project, and we receive very good feedback and a lot of interest, so we decide to open also to other sites. Right now we are covering 14 sites. Actually there is a 15 that is not in this slide because it's already on standby, let's say. And we performed in each of these sites at least one multi-stakeholder forum to start gathering the requirements. In parallel, we are creating a knowledge base that we call Open Keywords, because it will be open at the end of the project. And this the knowledge base is a collection of different catalogs, is an inventory of more or less whatever is there regarding inland water, regarding digital twins for inland waters, regarding the different aspects that we want to cover. So we start collecting policies, projects, open data. We are putting everything in a database, let's say. And it is the second input of the project. They are two actions that are going in parallel. Actually, we just have the first deliverable for both of them. We have the requirements that came from the multi-stakeholders, and we have the open keywords already there and already online. And it was the first phase, let's say, of the project. But now we have to do a mapping. Okay, we have these two big input, but how are they related? How may we interpret what we have in both of them? And so we started a mapping activity to check the gaps, to check what is missing, we check if what has been asked by the multi-stakeholder forum is already there, that could be, or if there is some policies that is a barrier that we have to make some changes or to propose at least some changes to improve it and to have this digital twin possible, this kind of thing. So we are doing this mapping. And in parallel, we need also to have some more concrete issue, no? Just to have something more tangible to understand what we are going to do with this future digital twin. So we are also defining what we call the reference use cases. That it means that for each type of water, as I put there, we are defining a use case together with, we are co-creating because we are working together with stakeholders, also in this case, to define which are the needs for this specific digital twin. For example, digital twin for urban waters. We sit down together with Aguas de Barcelona in Barcelona, in Spain, and we define together with them which are the needs, which are what they are expecting for the future. In the case you have a digital twin for free, what do you want? What do you think is useful for you? And it is how we are defining our so-called reference use cases. All this information, the results of the mapping together with the reference use case, is then used by our architects, software architects to define the reference architecture. So we are not developing the digital twin, but we are defining which are the modules, the components, the software components that will be part of the digital twin of inland waters. Of course, we don't want to reinvent the wheel, so we are using also everything that is already there that comes from the Open Keywords, and all the time we are taking into consideration the work in the digital twin ocean. We are in contact with the coordinator of the Edito Infra, so we are working on that to this definition, and in particular for the reference architecture is very important to take into consideration their work, just to be aligned, because also some of the modules or the components that we may decide that are fundamentals for our, let's say, digital twin, probably are already there. So we may confirm that they are useful because they are also there, or we may say, okay, it was something that wasn't in the digital twin ocean architecture because for ocean is not important, or probably because the stakeholders were different from ours, and so we can also improve their work. I mean, working together give us also this opportunity. And the final output of the project will be a roadmap that we'll give to the European Commission as an open document, and it will contain all the results of the project. So going more in details of each of the components of this concept, starting from the multi-stakeholder forums, the multi-stakeholders, yes. In this first part of the project, we already reached more than 350 stakeholders, and in the 14 country sites that I show you in the previous slide. And the first work that we made with them was sitting together virtually, I mean online or also in person, depending on the situation. And we start presenting them the project, presenting them also the digital twin ocean, that it wasn't, I mean, we are working with experts more on inland waters, so they are not aware, the majority of them weren't aware about the digital twin ocean, and we presented our idea for our solution for the future, and we checked with them in each of the country which were the most relevant type of water for each of country, because always we want to divide the problem in small problems to be more able to address them and to focus on specific problem to have a better solution. At least is our rationale. And then we started discussing the requirements. So in each country, we starting receiving feedback and gathering requirements, both functional and non-functional, from all the participants. Of course, we receive different feedback because of the difference in the expertise of the stakeholders, and also on the specific problem that they were addressing in their site. So it's a very good job also to have these different sites that are working separately. Then the focus for the future, it will be just at the end of the project to have a multi-stakeholder forum with everybody. But now we want to focus side by side. And in some of the countries and some of the sites, we also had some follow-up meetings, mostly with different people, just to have a different view from the same site of the results, and just to validate, let's say, the requirements that we gathered in the previous meetings. I'm not going to read, of course, this, but just to put the numbers of the people that we met, divided according to the quadruple helix, so researcher, industry partners, governments and agencies, also citizens and media. And at the end, this is the number that is relevant, is what we done in the first 10 months. I mean, I don't have the number for the 2 more months because the deliverable was for month 9. And yeah, as you may see, there are some numbers that vary high. For example, in Cyprus, that it was an in-person meeting, we reached 40 participants. I mean, it was very, very good for us and very helpful also to define the requirements and to meet different people with different expertise. And as a first result, together with the requirements, we define in each of the reference scenarios the 3 kind of type of waters that they selected as more relevant in the sites. For example, in the case of UK, river and estuaries, coastal water, and urban water were selected as the most relevant. And actually this afternoon we have a meeting to talk about coastal water, because at the end is the one that then has been selected among the selection as the relevant one to be considered here. So we did this job, and as you may see, Norway is the 15th one that has not been done yet, but we are working on that because we have contact there, and I mean, we will have some stakeholder forum also there in the second part of the project. So the result, a part of the selecting the kind of the type of water for each site, was to have also the requirements. We divide in non-functional and functional requirements. Non-functional are the most generic requirements that are related to what in general the digital twin should have, and for example that you give some guidelines to use it. I mean, we also divide in different categories just to order all the material that we receive from the meetings, and here I put some of the functional requirements, where functional requirements are those related to the functionalities that the stakeholders needs for the digital twin. And as you may see, we also put for each of them which were the sites that required that specific need, just to have the overall view, and also to use it for the definition then of the different use cases. And in fact, and in parallel, we worked on the open keywords, And we have 6 catalogs at the end that compose this open knowledge base. We have a catalog for EU and international policies and standards for inland waters. We have a catalog of project and information systems outputs. We have a catalog of scientific research results. We have a catalog of data models, AI technologies, simulation, intelligent systems, and digital twins related to inland waters. We have a catalog of inland water open data and sensing sources. We have a catalog of data and services from national meteorological organizations. So we are trying to cover all the things that we think we should need for the definition of the roadmap, for the definition of the digital twin, for be compliant with the requirements that we are receiving from the stakeholders, because we want to know what is already there at European level, basically, but not only, because we are also considering, for example, for the policies, we are moving also to the international view, considering also, for example, those from Australia. And so we are putting also other information, not only regarding to Europe. For the project, yes, that we stay in those that are as being funded by the European Commission, and we're trying to cover all these aspects, because we want to have this collection of data to be used as a knowledge base for defining the next steps, for defining the roadmap, and also to give this kind of information to end user in the future, because the open keywords will be delivered as a separate result of the project. It will be available online. Actually, the first version is already online, but not accessible to the public, because we are waiting for the okay by the European Commission that our work was good, was accepted. And but yes, at the end of the project, of course, it will be open. And and we already seen during our previous project board with the some project officers, that is something that is of interest for the Commission. To prepare these catalogs, this knowledge base, we use several data sources for each of the catalogs. Of course, I'm not going to read everything, but just to see that we consider different data sources, and sometimes we use some LLM just to be more just to avoid manual work, and to have some filtering that was automatic. For example, for the projects, we extract from the Cordix, for the Cordis, the list of projects, and we analyzed by an algorithm the results, just to select those that are relevant for our work. We work using keywords, but also some machine learning approach depending on the catalog. For example, also in the case of the papers from Scopus, and also from the results of the research project, we use some not manual process, because it's very huge, this work. I wasn't aware that it was so huge when we prepared the proposal, I must say, but it is what it is. And we have the numbers. For example, we have 5,430 scientific results. That is a very big number. And you may see, I mean, all the numbers are very big. Also in the case of project, we have 515 projects. So we have a lot of material. And now we have moved to a different issue. Okay. We are very good in collecting everything, but how we manage all this information, because at the end we want to use this information not only for ideation, not only to go to the European Commission, but only for our future work, because I mean, it is a lot of knowledge, and you know, today data and knowledge is the money, no, for research and for activities in general. So we want to use that, and we are thinking on some solution to have it easy. It wasn't in the first list of activities of the project, but I mean, we are engineers, so we want to not have to an Excel file, but we want to have something that everybody can use in the future. So, starting from these two inputs, the requirements, let's say, just to summarize, and the catalogs, we are performing now a mapping. Requirements from one side, the open key was from the other side. We define some categories, it's not the full list of categories. We define some categories just to start a match using LLM to match the different categories. And actually, Joan is working on that these days. And so, starting from this categorization of the two inputs that we have, we want to have as a results which are the missing capabilities, which are the existing tools that may have performance issues, and also if there is some problem of some lack of scalability. So we want to have this to check in particular which are the gaps and the limitation from the right part of this slide, so from the open keywords that are required by the left part of the slide, just putting everything together and to have a solution, to give a solution for in our list of recommendations at the end of the project. I mean, we are not then covering what it will be the results of this mapping activity, but we will make a list of recommendations for the future development on the digital twin, highlighting and pointing out what is missing and what should be covered by the future digital twin. As I said, in parallel, we are also defining the reference use cases. It is something that at the end, all the experts in the project will start asking for, because multi-stakeholders start asking, okay, we are defining requirements, but for what? I mean, we need something more tangible. And also, okay, we are performing mapping activities, but what we are going to have at the end, and also for the reference architecture, the same, no? In the sense, okay, this architecture is for digital twin, but something more concrete. And so we start to define the reference use cases. Also in this case, we decide to follow a divided in pair approach. So we decide to have one reference use case for each type of water. And so starting from the previous list that I showed in some slides ago, we select in which site to consider the reference use case. So Switzerland was the candidate for snow and ice, also because our expert that is placed in Switzerland. Greece covered both river and estuaries and wetlands. In Italy, they are covering lakes. In Cyprus, reservoirs. In the Netherlands, groundwater. Here in UK, coastal water. And in Spain, we covered urban water. So in each of these sites, we are sitting, because it's a work in progress, it's not finished yet. We are sitting with our expert, and we are co-creating these reference use cases, because we have the knowledge about the digital twin, we have the knowledge about the digital twin ocean, we have the overall list of the requirements, but for example, we in Spain, we are part of Veolia, we work with Aguas de Barcelona, but we are not the water operator, so we need a real expert, the one that then in the future is going to use the digital twin and should say, okay, in my near future, I want a digital twin that do this and that. So we can give ideas, but we need the expertise to define. So it's for that that we decide to have a co-creation approach. And I put here exactly the example of the digital twin for urban water. That is the one that has been defined together with Aguas de Barcelona. And for each of the reference use cases, we are defining, of course, the country, the type of water. We select one or more stakeholders. In the case of urban water, Spain, we decide to focus only on Aguas de Barcelona. It's true that we are Viola Spain, so we have access to a lot of water utilities, but each of them is working differently and separately, so we prefer to focus just on one. And we selected Aguas de Barcelona also for proximity. And in each of the reference use case, of course, we have to identify who is the end user, who is going to use at the end, in the future, this digital twin. In the case of urban water, is the water utility manager. With them, we sit down and we define the problem. So the problem that is now in Barcelona and for the water utility, for basically in all the Spain, but also in Barcelona, is a problem on water scarcity. Is a problem of low reservoir levels, is a problem of the climate change impact that is changing how the water utilities may operate and how they have to worry about drinking water in this case. And so once we have defined the problem, we define the different challenges that this digital twin should cover. So they ask for something that is able to predict future water availability, something that is able to forecast and to predict and to assess water quality. Of course, talking about drinking water is very relevant, the quality of the water, but they want also to take into account cost assessment. They want to have advanced forecasting capabilities to predict through the forecasting also the levels of the reservoirs, for example. They need something that is able to integrate multiple data sources. That is an open project, an open issue in the water sector. But I mean, at least in theory, they want to have different data sources. Then they will start problem how to share data, but it's a different problem. It's not our problem right now. They want something that is able to help them and to support them in making decisions. And they are worried about regulatory compliance because they, as Aguas de Barcelona, must be compliant with the regulations, so they must know if the process that they are actuating is compliant or not. And so at the end, we have this definition, let's say, of requirements that is listed here, that is what, according to Aguas de Barcelona, should be a digital twin for urban waters. And I'm not have here because it's a work in progress. We are also describing each of these reference use cases in a visual mode to also help not experts to understand which is the final goal of the digital twin, because in Aguas de Barcelona we have talked with experts, with researchers, the people more from the innovation department, but of course if then we want to sell our solution to Aguas de Barcelona, to the manager, to the people that are operating there, of course we need also some visualization improvement, so we are working on that, and we will work on this definition of a visual solution also for all the reference use cases. So basically is what has been defined that our colleagues together with us in Aguas de Barcelona, and for example, as you may see here, it was after the flooding in Valencia. So of course, also in Barcelona, they are very worried about that, and one of the things that they were asking for is a what-if scenario to be able to forecast, to predict, and to be able to actuate in the case like that. And if we move to the energy sector, yesterday we had the big blackout in Spain, so also what-if scenarios, a digital twin for electricity, it would be useful to know how to, because, I mean, there was a mess with metros, train, and we were lucky, John and I, because we were able to come here, but then everything started like metro that don't work and this kind of thing. So, I mean, it's an example where a virtual replica could help to give some information, to give some solution when some emergency situation and unexpected situation appear. And also, I mean, we are thinking about the future. We are not going to implement the digital twin, but we are people that thinking ahead. So we want to give to the European Commission also a view of which are the strengths, the weakness, the opportunities, and the threats of our digital twin or our digital twins, depending on how we want to see the different twins for the different type of water. So we started, in particular Albert and Kate, that she's not here, are working on that to define for each of the digital twin identified in the different sites for each type of water, that it means the corresponding reference use case as SWOT analysis. And here I put the one, since I put before the urban water, I put the one regarding the urban water, and again, we sat together with the expert and we asked them, okay, I mentioned Kate, and Kate is here. Sorry, a little bit. Okay, you knew that it was the SWOT
yes,
slide, no?
I do know this, yeah.
Okay, so we define for each reference use, we are defining for each reference use cases as SWOT analysis. This is the case of the urban water. We sat with the expert, we sat again with Aguas de Barcelona, asking them, okay, in the last meeting we defined the reference use case. Now what? Which are, in your opinion, the strength of this digital twin that are not covered right now, but also which are the weaknesses, what we are adding that wasn't there, but now with the introduction of digital twin we are considering. The same for the threats. I mean, we are trying to putting everything together because we want to have an overall view at the end of the project of what we are doing, thinking on the future. Because if then Aguas de Barcelona is going to have this digital twin, they must know what they are putting there in terms of, for example, there is the risk of cyber attacks. That is something that they don't have now because they don't have a digital twin. But if they are going to have a digital twin, they have to think into account this. And so they have not only to have the digital twin, but also to think ahead and to think how to win on a possible cyber attack. So everything is relevant for us, and we want to put everything together just to have the final view of what we are providing to the Commission. We are not going, I mean, it's a European project, but it's not something theoretical. We are working with Aguas de Barcelona, that is a real water utility. Here in UK, we work with the Southwest Water, so they are real. They are not just a piece of paper where we put whatever we want. So it's very important to have this kind of analysis. And it's more, starting from all of that, we have to define also this reference architecture. That is something more technical that we will give when the European Commission will accept our roadmap and they accept our list of recommendations, there will be some developers somewhere in Europe that will have to define, starting from the reference architecture, the technical part of the DT, and so we are working with the software architecture to define the reference architecture. And so we defined these very high-level modules, that is what it is expected to have a digital twin. These 5 modules came from experiences that we had in the different in previous projects. For example, in the case of our colleagues from engineering, they work in digital twins for other applications, so they starting to have this abstraction of what it is needed. And so this is the 5 main components: data collection and management, processing and orchestration, interoperability and integration, usability and visualization, scalability and reliability. So this is very high level what a digital twin should have. And then we started studying the baseline. No? We have to studying the fundamentals of digital twins. In our case, our fundamentals is the digital twin ocean. So we started checking what they are doing in the digital twin ocean, starting to learn from them and studying their reference architecture. But not only the digital twin ocean, but also the work that the European Space Agency is doing with a different digital twin, that is the digital twin of Earth, so the destination Earth, or Destiny, if you prefer. And so we are starting from the big bosses in this field to check what they are doing, and also to be compliant with them, but also, as always, to understand what is going on in the rest of the world, but at European level. I mean, in this sector of digital twin. So starting from that, we define this preliminary. Is not the final version, but is almost the final version, because the deliverable is expected by the end of next month. And it is the first version of the architecture. This first version will be then improved in the second part of the project, in the second year of the project, thanks also to co-creation approaches together with stakeholders, because we will start in September new multi-stakeholder forum with new meetings where we start receiving not anymore requirements but feedback on what we already done. So we will interview also experts on architectures, developers, this kind of experts, just to have feedback also on the architecture. Of course, I'm not going into the detail of the architecture right now. And the last point is the biggest results of the project, that is the roadmap. The roadmap will include more or less everything. I mean, all the things that I explained right now will be there. So we will provide a roadmap with the requirements, functional and non-functional, the updated version, because I suppose that in the second part of the project we may have time, thanks to the multi-stakeholder meetings, to improve these requirements, and also from what is happening in the reference use case with the expert, validating the reference use case. I mean, we have a lot of interactions, so this list will be, of course, updated and will be part of the roadmap. The reference use case will be part also of the roadmap, of course, because we have to give example for the future development. test what analysis of each of the reference use case will be part, and also if at the end we will be able to have one unique SWOT analysis for this big digital twin, we also have this one, but I mean, everything will be there, and of course the reference architecture, and of course any data sources that we identify that it will be useful for the definition of the digital twin. Of course, all the interfaces for interoperability that we may found and that we may consider relevant for interoperability, in particular with the DTO. Of course, technical recommendations, how to interface with the digital twin ocean, technical governance, and we will perform also assessment, technical assessment, life cycle assessment, life cycle costing assessment, and social economic assessment. And that this activity will start in the second part of the project, so I have no idea at the moment on how they will be performed, but they will be part of the roadmap. And that's it.
Wow. Thank you very much, Ella. Any questions?
Hundreds.
Yes, okay.
Sorry, will you go for it? Hi, thanks very much. That was very interesting. We have a lot in common. I'm Dan Morton. I'm work for a company called Argans, and I'm project manager for coastal processes and extremes digital twin in the Destiny program. So I was just wondering how developed the relationship between the DTO and Destiny is, because it looks a lot of the things that you're doing, certainly with regards to the reference architecture, I think are already quite well developed within the Destiny program. So I was just wondering how strong the links were between the two programs.
Actually, when I read the documents for the digital twin ocean, they already mentioned the Destiny, so they are already considering each other. At least DTO is considering Destiny, and so it is something. Sorry, that it's supposed to be already there. But we are analyzing now, our colleagues, which are the specifications, the technical specification of Destiny, of the architecture, to see which component, in our opinion, should be also part of our reference architecture.
I mean, it's important, I think, with both sort of...
Yes, also because Destiny is already started, is already there. There are a lot of